RL circuits A. So here's a circuit. Determine the value of this circuit's time constant, tau. For an RL circuit, the time constant is found by taking the inductance over the resistance. That's going to be 6 henries divided by 3 ohms, 2, and the unit for the time constant. We could say henries per ohm, but let's change it to seconds. When the switch is first closed, what's the current in the circuit? When we close this switch here, how much current will there be in this circuit? And the answer is 0, because an inductor acts like an insulator for an instant at time equals 0. How about at time equals infinity? What's the current? Well, then the current is just going to be 10 amps, 30 volts divided by 3 ohms, because at time infinity, the inductor just acts like an ordinary wire. Let's draw here approximate graphs, and we're going to label any non-zero asymptotic value. And on the graph, we're going to indicate where one time constant tau comes into play, and we're going to specify the x and y values at that location. Across the resistor, we said there's no current at first through the resistor, so that must mean that the voltage across the resistor starts at 0, and eventually it's going to end up at 30 volts. That entire 30 volts will be dropped across the resistor at first. The inductor fights with 30 volts right at the beginning, and then it drops off until it's acting like an ordinary wire at time infinity. The current, we said, started at 0, and it climbs to a value of 10 amps at time infinity. The last part here, it says, indicate where one time constant comes into play. We said that the two fractions that are relevant whenever we're dealing with time constants are 0.63 and 0.37. At a time of 2 seconds, which is what the time constant was, we figured that out on the previous page. For this first drawing, we are 63% of the way up. 2 seconds might be right there. There's tau right there. And I know that because that right there is about 63% of the way up. The x coordinate here is going to be 2 seconds. And the y coordinate is going to be 63% of 30, which is roughly 19. I'll round it to significant figures, roughly 19 volts. That's going to be the voltage drop at 2 seconds. Then that will continue climbing as time goes on. Similarly, for the next one, this is going to have dropped to 37% of its original value. These coordinates here are going to be 2 seconds. That's going to be on the x-axis here. And on the y-axis, it's going to have dropped to 37% of what it was, which is the two significant figures, 11 volts. Same sort of idea here. Not a great drawing, sorry about that. 2 seconds. That's going to be the x-coordinate, and then the y-coordinate is going to be 63% all the way up to 10 amps, which is about 6.3 amps.